Good morning, everyone. Thank you for joining today's webinar session. We're going to look at a drainage management solutions series. The first product, InfoDrainage, is the key focus for today's stormwater and sanitary sewers session. Mainly, I think we're going to focus on the stormwater management. My name is Prem Joseph, technical consultant with SolidCAD, and my background is civil engineering and in this field over 20 years now, delivering this Autodesk solutions, consultings, and trainings across Canada. I am looking at the list of the attendees, and I know some of you guys already attended a few trainings and seminars. Just before getting into the product, I just wanted to give you some heads up. If you have any questions, feel free to ask, or type in the chat window. We will be addressing the questions, and if there are certain issues need to be go in detail, we could take it after the seminar and discuss it further too. So feel free to convey your comments and suggestions or questions as we go through this webinar. The product InfoDrainage, if you haven't heard about it, that's one of the software from the collections by Innovize Solutions. Autodesk acquired this company, I think last year. And we have a good set of tools now focusing on water engineering. The InfoDrainage product is a concept to detail the design a software in the planning permission of for any development is really depending on a solid stormwater management strategy. As we all know, our industry is getting more focused on green infrastructure and sustainability. That is leading into a number of increased constraints and project costs. So it is very important to get things right first time around. Delays to construction or stormwater permit approval can impact consultant engineering firms' credibility and also margins. To measure the project efficiency, we need to track different aspects of the drainage design across multiple packages. To get approvals, quicker the model must demonstrate compliance to local standards. To achieve optimized sustainable drainage design and BIM workflows, typically a number of design iterations happens throughout the project cycle. And we definitely don't want to start all over it again. So we all know recreating design data from one format to another is time consuming, and we need to avoid that scenarios. A single automated drainage design platform in compliance with the BIM workflows, that's what InfoDrainage is offering. In the agenda, today we will be reviewing the interface of the software. I'm going to run a few designs, pipe designs, and looking at the steady stage analysis, volumetric analysis, also the round trip of the stormwater system from Civil 3D to infra drainage and then back to Civil 3D, right? So we will see how that can be done efficiently. Also, the product offers excellent tools for pond design. So I'm going to show you guys some of the features of pond design capabilities in the product. Also, the software has a good collection of sustainable drainage system design options, sets. So we're going to take a look at it, and some excellent ways of reporting the information out of the software too. If you look at the water industry, the life cycle of water from precipitation to evaporation. This picture explains a lot of components going in. We use water for irrigation, drinking, residential, industrial, and many other areas. You could see there water treatment plan, sewer treatment plan, STP, RTP means, regional treatment plan, SWRO, which is seawater reverse osmosis system, which happens many parts of the world. So when we are dealing with this stormwater management, our focus is more on getting the runoff and then do the design. So we are focusing a lot on the runoff, evaluating the conditions and getting the numbers to determine the runoff, and then based on that, we could come up with the design. Some of you guys might already know there is another product from Autodesk called the Storm and Sanitary Analysis SSA, which ships with Civil 3D. And here is a comparison chart between the SSA and InfoDrainage. Some of the key items, you have the complete, hydraulics, hydrology techniques built in with InfoDrainage, while SSA is a bit shy on that area. When it comes to Civil 3D interoperability, InfoDrainage does a fantastic job. Also with the BIM workflows. There's so many, plus points you could see in this chart in comparison with SSA. When I talk about the sustainable drainage system, here are a few pictures just to give you an idea. Okay, pond, obviously that's a said swale, chambers, cellular storage, infiltration trench, bioretention, porous paving. There are so many items available in this product. When you look at a larger subdivision development, we know where the pond is going and designing the pond, then the stormwater management system. By introducing suds in between, maybe a swale or a cellular storage or porous paving in between few areas, that could significantly control and contribute the stormwater system, and you would be able to reduce the pond size sometimes even 50% by adding 2 or 3 sets into the bigger picture there. So that kind of design is getting really popular in many other continents. Over here too, we could apply these techniques along with the traditional ways of handling stormwater management. When you look at the product licensing and the way it is bundled by Autodesk, there are 2 different flavors. One, it's a standard version and an ultimate version. It's a standalone product. You could get a separate install, and the ultimate comes with a Civil 3D add-on to do the round trip between Civil 3D and InfoDrainage. Also, only the ultimate offers sustainable drainage systems in it. Also, there's a 1D, 2D analysis. So there's a big difference between the standard and the ultimate edition of this product. When we deal with the pipe design, it's so easy to make the flow paths and a lot of information you could display. They're all dynamic profile views. You could export these, trade these with other packages or other file formats. Very easy to use dynamic profile views. You could incorporate rainfall data and then do the analysis based on the available information. Storm systems. You could have multiple storms and durations tied in with the analysis. You could do detailed analysis, not only storage analysis, volumetric analysis. And when it comes to pond design, it's a criteria-based approach. Catchments, we need to define the catchments and apply the minimum parameters for the catchments. Runoff coefficients, percentage, impermeable, and a lot of factors we're going to apply. When you run the simulations, you can check the capacities for various scenarios, then resize your pond. There's so many tools available inside the interface to help us to get a better design based on the available conditions and design guidelines. All right, so let me get into the demonstration here. The product InfoDrainage, Windows-based application. You have different tabs on the ribbon showing a set of commands or functionalities available. Left side, it is a tree view, something similar to Civil 3D tool space with the available objects and informations will be populated, including the analysis here. On the right-hand side, we have a toolbox to create objects, edit objects. So some of the options, if you look at connections, could be pipes, box culvert, channels, no delay for just analysis kind of purpose, custom connections you can define. And the stormwater controls are the sustainable drainage systems. You could see a variety of them. Inflows, catchment areas, green roof, base flow, etc. There are so many tools available. So let me open up a simple pipe network and review some of the information. Then I'm going to add a pipe and a catchment area. Then we'll do some analysis. A simple design with few pipes and catchments. On the left side, I could see a surface is already available. I'm going to draw a pipe and catchment. So I'm going to simply using the snap tools. So I can snap to the endpoint. And picking the pipe option, snapping to the endpoint, and then connecting to the next manhole there. So it knows the directions, when I'm connecting, so it's connecting from the other pipes, it already knows that the flow is coming from the other direction. And when I connect the pipe, it's assuming or taking the previous direction. Now for the catchment, it's under the inflow. I could drag and drop the catchment and then snap to the AutoCAD geometry or CAD geometry background to get this catchment information. I could go and verify the info for the catchment. So volumetric coefficient is 0.75, percentage impervious is 100. That's not something we typically do. We generally go with 60% or slightly above. Okay, well, we can settle on 60%. And the other parameters, time of concentration, 5 minutes is general. So I could input these numbers one by one or apply them in a global way. So I have a number of catchments. I need to make sure all those catchments has the same parameters. So loading the tables. Under the inflow, I could enable the items in the table. So mainly, I'm interested in the volumetric runoff coefficient, time of concentration, and percentage impervious. So I could see the percentage impervious is 100, highlight them all, applying 60, time of concentration 5 minutes. I'm good with that. Volumetric runoff coefficient 0.75. Okay. Apply OK to get that numbers assigned to all the catchments. Now I want to take a look at how the pipes are currently laid in this drawing. So I'm going to go to the flow path and add a pipe run and going to take a look at the profile view. So I could see that pipes are currently laid on the surface and no design or anything happened yet. And everything is 100mm pipe. Okay. So we're going to associate some rainfall data and then run the design. So under the rainfall and pollutants tab, we have the rainfall manager, and there are tools available here to create your own rainfall data. I made one just based on the data available from my city of Mississauga. So I'm going to load that. So that particular data has different rainfall period, 2-year, 5-year, 10, 25, 50, and 100-year from the example I got. So I'm going to use this 5-year rainfall period. And then the next thing is to run the network design criteria. I could go in and choose a rational method from my library, the rainfall data. You could control a lot of parameters here. The minimum time of entry, 5 minutes, that's the one we went with. And the maximum 30 minutes, if you don't want that, you could adjust all those numbers. Under the design options, so this is where we could add a lot of information. So it's going to run the design and come up with pipe sizes. So then if you wanted to let the software follow a certain standards for the pipe sizing, I could go in and update the libraries. So for example, 100 millimeter is the smallest diameter, then 150. Then say if you want 75 millimeter increment, the next one will be 225, then 300, 375. Or if you want a 50 increment, you could add 50. So it will be 150, 200, 250. So you could control these pipe sizes. Okay. Same techniques for the manhole. By default, it has certain sizes, and you could add more and control the way you like it. Okay. Another item, so when you do the design of this network, how do you want to approach it? Level inverts or level soffits? I had a couple of construction company friends, laying out these kind of pipes. They mentioned to me, it's easy for them to go with the level soffits when you place them rather than level inverts when you're putting these pipes under the ground. Okay, if that's the case, we could do that. Or if you're going to go with the level inverts, that's up to you. Then what's the minimum cover? You can specify a minimum cover. And another area to pay attention is the velocity. When the water flows through this pipe, these are big pipes too. You need to control the velocity, minimum maximum velocity. You don't want this going too fast and damaging objects around it. So you could control the velocity. There are lots of other controls too you can apply. I'm going to go with these options and say OK. And ready to run the wizard. So this is going to do the steady stage analysis. So that's the current info. It's telling me in this dialog box, you have all 100 millimeter pipes, and these are the available parameters, the levels, and all the information. I'm going to say go next and use my design criteria. I'm going to go next. Is reviewing again. If you want to make any changes at this point, you could do that too, changing the velocity or cover value. And this dialog box, now the result came up. So I could see there the 100 millimeter pipes, the first two changed to 150, and the rest is 225. And my velocity is between 1 and, from 1.5 to 2.075. So between 1 and 3 meters per second. So I'm good. I'm going to say finish. And another area to check over here, the capacity. What is telling me, the first pipe, the capacity is 28.2 liters per second, and the flow actually coming into the pipe is only 12.78. So I'm really good there. So you can do that capacity versus flow, and the last pipe, when all the flow gets into the last pipe, the capacity that pipe has 82.488, and the total flow coming in 81.03. So I'm good. So there are a number of checks we can do, and it's helping us with these nice reports as we go through this design process. Now I can review my flow path. I could go here and show the profile. So you can see the new profile updated with the new pipe sizes and the invert values, slopes, everything in here. Okay. Now we're going to take a look at Civil 3D round trip. If you guys are familiar with Civil 3D, it's a product for civil engineers, infrastructure, design, detailed design happens in this product. So in my drawing, I have a surface with a triangulation. You could see a pipe network. I have a stormwater pipe network going on and a bunch of catchment area. You could create these catchments and pipe network in Civil 3D. So when you make the pipes, it's more like drafting inside Civil 3D. We are not designing, just drafting the network. So this particular network looks like that's 0.4 meter, that's 400 millimeter pipe. So they have a few 400 millimeter pipes, and the last one 600 millimeter pipe, and few structures there. I'm going to check this catchment properties, see what information we have already there. So the catchment is connected to the catch basin 1, CB1, and the runoff coefficient is 0.5, okay, and is using TR55. Time of concentration 0. All right. So what I'm going to do, take this data into InfoDrainage. So when you have the InfoDrainage Ultimate installed, you can see on my screen there is an InfoDrainage ribbon tab with commands specific to InfoDrainage. So I'm going to use the export to InfoDrainage option. So when you do this export, it will take the pipe network and the catchments. Okay, those are the two things going to go into InfoDrainage. I'm going to select a file name. It's January 31st. And the next window is prompting to pick the network. If you have multiple network, you can do that. Select which network you want to go. You have the ability to export the surface if you want to take the Civil 3D surface from here over to InfoDrainage, you could do that. I already have a surface built in InfoDrainage, so I'm not going to export it. So there's an option. Then the next dialog box is the parts mapping manager. It's telling us in this current Civil 3D pipe network, two types of 400 millimeter concrete pipe and 600 millimeter concrete pipe is being used. When I'm taking it to InfoDrainage, that's going to happen, 400 and 600. Junction mapping, okay? So mainly you need to pair, if the columns are filled in, you're good. If it's not, then you may need to pick and choose the size, okay? Right now it looks like it is filled in. So I could do a finish, so it will export this data. Switching to InfoDrainage, I'm going to open that particular file we just made. I called it January 31. The data came in. Catchments, pipe network. I am going to load the surface, which is available as an XML file. Okay. It's asking whether I wanted to update all the levels of the pipe network based on the surface. I'm going to say no. So let me update this catchment information because I need to give some realistic values and numbers for the catchment info. So I'm going to go to my build option tables and get all the inflows with the numbers I want to go for the design. So mainly percentage impervious, I want to go with 60, and the time of concentration is 5 minutes. And runoff coefficient 0.5 is too low. It's going to go with 0.75. Apply. So my catchments are ready for processing. Now I'm going to take a look at the profile view, creating a pipe run, selecting the first and the last nodes, drawing the profile view. That's how it looks like from the Civil 3D. Okay, we're going to do the design here. I want to make sure I have my rainfall data loaded. I'm going to the preliminary sizing, loading the rational method and all those information, design, etc., etc. I'm not going to modify any settings. It's going to use the previous setting and run the design. So let me check this criteria. That's all good. So that's the current numbers. Once I run the design, it's going to give me the new numbers. 225, 375 are the pipe sizes. There's a bit of warning at the end saying because the minimum cover is not met for the last piece of the pipe. So that's in that drawing based. Okay. Flow, capacity versus flow. I'm looking at the numbers. I'm good there. And going to double check the profile view. You can see the first one is 225 and then the remaining pipes are all 375. Okay, I could save this info. Once the file is saved, all I need to do in Civil 3D, import from drainage. So this command will override the existing pipes with the new pipes, also the manholes and the catchments. The catchment objects will be updated based on the incoming data. So I'm going to load the InfoDrainage file here and looking for the options here. Load surface from the other one. We don't need it because Civil 3D already has a surface. Use the existing Civil 3D surface. And the next one is the part mapping option. So the incoming data, and based on the current parts list and the catalog loaded inside Civil 3D, we get the options to pick from it. From Civil 3D part family, okay? So I need to tell, okay, the incoming data is 225 and 375 pipe sizes. Make sure I select this. Okay, that's on the pipe side. Now onto the junctions, we have two sizes coming in, 1200 and 1350. I could choose the correct part size. Once those items are selected, all I need to do the finish, it will update the existing network. Okay, so I could hover over to the pipe, and that should be 225. This should be 375. And if I go to the catchment infos are updated to 0.75, 5 meter, and user defined. So the round trip is smooth from Civil 3D to infrared drainage and back to Civil 3D. Okay. The next item I wanted to show a pond design. So here is the criteria for the pond design we're going to try. So the base level elevation, I want 30.434, top water level 32.109, and 200 millimeter freeboard, and the depth is 1.675, right? And there's a side slope 4:1, mainly just for, if somebody's falling in the pond, safe, smooth going. It's not really huge impact on the design but slope we provide anyways, a good slope. And what we're going to do, first we're going to design the pond based on our criteria in a subdivision, and then run this for a number of storms and look at the pond volume. After that, we will introduce some of the sustainable drainage systems and then rerun the analysis, take a look at the pond volume and see if that can be reduced. Okay. So let me open up a pond design file. You can see a subdivision here with a number of catchments and a good collection of pipes and structures. So I want to add a couple of items before we get to the design. So I'm going to add a surface. No need to update the level, so the surface is behind the scene. Okay, I don't have to turn it on. And we have an outline for the pond. I'm going to bring it from the CAD drawing, so AutoCAD line work. Importing the data, I could choose the pond outline and hit the next. It's showing all kind of layers here coming from AutoCAD, and I'm going to select what I need and place it there. So that's where the pond going to happen, right? So let me delete this pipe so we don't need the pipe, and to control the visibility of these annotations, looks like a bit big here. I'm going to apply the display settings, something like that. Let's see. Okay, that looks better. To create the pond, draft the boundary first or import it first. Then you could snap to the existing object. Now I'm going to look at some of the numbers here. So this pond, our criteria, our base level, which was 30.434, and our top water level 32.109. Okay, so 1.65 and the freeboard 200 millimeter. So I'm putting some of these numbers to begin with. So the total depth is 1.875, and I'm going to start with something kind of like a rectangular shape. Under the sizing calculator, we have many options. One of them is a side slope. We want to provide 4:1 side slope. I'm going to go with that so it can see a shape going in. And it also allows me to do the volume calculation here. So before we get into that calculation, a couple of other items I need to double check here. We have a number of inflows or catchment areas. I need to find out the total area or here to do some computation. I'm going to look at the results inflow summary. So my entire catchment is 4.201 hectares. And the area analyzed is 2.521. So based on my other parameters, percentage impervious, runoff coefficient, the actual area for this computation is 2.521. Okay, so that's what I need for the pond design. So to go back under this pond design, we'll get into the sizing calculators. Okay, another one here. What do we have? Quick storage estimate. We're going to go with the freeboard. And under this volume computation or quick storage estimate, I could go in and apply some of the numbers, right? So the area 2.521, runoff coefficient 0.75, the discharge rate. I'm going to go with the 16.1 again, depending on your local gate lines, or look for the numbers when you do this kind of calculations. Discharge rate 16.1 liters per second. I'm putting in there, and the storm we're going to analyze in the design. Number of storms 18. The way this storm is set up, they looked for the severe storms in the summer season and the winter season. So 9 summer storms and 9 winter storms. Okay, total 18 storms. So I could hit the calculate, and what it is telling me, based on those numbers, it is approximate around 705 to 997. Okay, that's the number you can begin with. When you say, okay, the software will get the average value, and that is kind of like the initial numbers. I could also go in here at the advanced, under the Manning's coefficient. I need to apply a value 0.03, and okay, so you can see now the pond size is bigger. Previously it was like a small boundary. The pond sized accordingly. If I don't want to display the CAD data, I could turn it off. Now it's a matter of attaching the inlets and outlets, right? It's a connection. So I could do by adding a pipe, or just for analysis, I could do a no delay connection. Starting from there, I'm going to pick somewhere around over here. Another one, this is for the outflow. Okay. So we're going to say, okay, from this pipe, this manhole water has to go into the pond. So I need to go into that manhole and under the outlet, provide a diameter. It already knows, okay, there should be an orifice, otherwise, water is not going to go, right? So it put an orifice there in the existing manhole. And all I need to do, provide the diameter. I could provide a diameter, or I could calculate the diameter. There is a calculation button. You know what, let's do the calculation for the other one. For here, from the pond, it's going out, right? So I'm going to go select that object. So we're going to do some calculations for the diameter. Let's say, okay, design depth is what, 1.675. Flow, I think 16.1 liters per second. Okay. Coefficient of discharge 0.6. I'm going to say, okay, so it calculated a diameter for the orifice. It's too small, that diameter 0.077, which is like 77 millimeter. If you wanted to, well, that's the minimum size, okay? You could increase the size, that's all fine. And I can say, okay. So those two conditions looks fine. What if we're going to hit a 1 in 100-year storm, and you definitely don't want the pond to be flooding? So how can we avoid that situation? So we could maybe, I could provide a weir or some opening here. We can tell, okay, when it reaches to this water level, right, close to the top water level, let that weir be in action and water flows through the opening or things like that, right? So I'm going to address that situation. I'm going to put a symbol junction here and a no delay for starting from somewhere around here, touching over there. And this particular object, I'm going to change to weir. You can see a lot of different outlet types are available, right? Pump, siphon, hydro brake, V-notch weir. So I could choose that weir, then provide, okay, in this case, I don't, well, care about, not too picky on the size, but okay, 3 meter wide, plenty of room for the water to flow, okay? So I could do that. And also the crust level. So when you say the crust level, this elevation is your top water level elevation, right? It was 32.108, or I'm going to go to 32.1. Apply, okay. So it's all set now. Let me add a pipe run or a flow path. I could pick beginning and end and show the profile view to get an idea how that's laid out in the system. And now we are ready to do some analysis, flood analysis. So I'm going into the analysis criteria. We could choose the storm, and there are a number of additional parameters if you wanted to include the urban creep global value, junction flood risk margin. Urban creep means, if you have if you look at an existing subdivision, we have driveways and roads and curbs and gutters and all kind of stuff. There may be cracks, water may be creeping through these areas going down. So if you know the percentage, you can apply those percentage. That's very, very, going in detail. Junction flood risk margin means, from the top level of your manhole, okay, you can see, okay, the water coming through the pipe, you don't want to reach the water up to the top, maybe up to maybe a 300 millimeter below from the top. So you can apply additional information to if you wanted to go into that kind of details in the design. Anyways, I'm going to go with the default one and I'm going to see validate it, see if it's good. That's okay. And I could run the analysis now. So it is going over these number of storms and checking with the design, looking for all the options and analyzing it. Depending on the size of the project, number of storms and other criteria involved in it, it might take a few minutes. But here, let's see how quick it's going to go in. So once you set up your network with all the information before running the analysis, always validate it. So the validation will help you to fix the error messages or any other issues associated with that. I'm going to go for the all storms critical option. We could see what's going on here. All items. I still have 5% of volume available in the pond. So that result looks okay. Now, I could show you guys how the design can change a bit in a better way when you introduce some of the sustainable drainage systems. So I have another example here. Due to time constraints and limitations, we have already the sets created in this. So I have a swale placed in and a cellular storage going in. So you could use any of those techniques. That's the same project, a different phase or different scenario. I could check the surface. I could turn on and off the inflows. So we're going to run the analysis in this one. Under the analysis criteria, I want to make sure all those items are checked in and running a validate option, then analyzing it. While it is running the analysis, I think there is a question, why did the pipe turn red from analysis? The reason being, those pipes are surcharged, okay? We'll see that result here too. You could, I think I have a 100-year storm or something going in there, like a big one. A couple of storms are really bad in there. And the surcharged pipes will typically highlight in red. So let's take a look at these three options. We have pond, swale, cellular storage on a critical condition. Okay, this is the number I want you guys to look at. After introducing swale and cellular storage, the pond Now 40% is available. Previously it was like only 5%. Now it's 40% of that area is available. That means I have a huge pond. I don't need that big pond. So we can resize the pond. I will simply go to the pond properties. Under the sizing calculator, so we had now volume 795. I'm going to change that to go down by 400 cubic meter. Okay, almost half of the size. Let's see if that's going to do the job here. We'll go back and validate, run the analysis. So while it is doing the analysis, I just wanted to mention that you could do this analysis for storm network, simple pipe network. We call it volumetric analysis. Check for flooding and things, multiple storms. So if you're designing a new subdivision, putting a set of pipes, need to run for analysis based on the available data, get the rainfall info, and then run it for like 5-year, 10-year, or 25-year, or even a once in a 100-year big storm scenario, and you will find a number of items and detailed challenges sometimes that need to be addressed when you're running all these multiple storms. So it's really helpful. So now we can see, even though I reduced the pond size to half, almost half, I still have some room left there. Okay, 2%, 3%, 2%. So that's good. So that's how we could use this tool to take advantage of designing better ponds based on the multiple storms scenarios. Okay, so that's what I wanted to demonstrate today on this webinar. If you guys have any questions, feel free to ask or type it in.